Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
Welcome to this Advanced Tips and Techniques video series. This is episode 14, Advanced Modeling Part 10. And today we are going to discuss fillets, and namely how to use them, but more importantly, how you can get them to work for your particular situation. So we'll be covering a number of tricky fillet applications, and hopefully one or more of them can work for you. So we're going to just introduce the fillet types very quickly and then talk about up to 2020's SolidWorks version, what options are available for each of these types. And then we'll quickly do the 4 different types to walk you through the property manager. And then we'll get into some more challenging fillet applications and some workarounds that I can instruct you on that will help you overcome cases where you can apply a fillet. And I'm sure we've all been there. So hopefully some of the recommendations that I give you will be able to get you around your current fillet problems. SolidWorks provides one fillet feature, and within that fillet feature there's 4 different ways of applying the fillet. The most common and default would be an edge fillet that you apply a constant or circular round to by a certain value. The second way would be to, on that edge or edges, apply a variable fillet. That is, the value or radius of the fillet varies along the tangent edges of what you're applying it to. The third type would be a face-to-face fillet. This one is where you can get pretty creative with hold lines, because you could define split lines on the part and then start to apply constant and C2 fillets and further define the shape of the fillet as it goes along the edge. And then the fourth would be a full round fillet, where you select 3 faces, and the distance between the first and last face determines the value of the radius. With each of these different ways of applying a fillet, there are different options. And as you can see from this graph, the default edge fillet has the most options available to it. And we'll talk about each one of these as we go through some examples further in the episode. You can see the least amount of options really exists for the full round fillet, because it can only really do one thing, and that is do a full round fillet between 2 adjacent faces with an intermediate face. So I think what I'll do here is to explain these options you can see before you. I'll just go through a number of examples, and we'll try to get through all the options, show their advantages and how they can be applied to your product design. So with this simple model, I'll just walk through these very quickly and then we'll get into some more interesting applications of fillet. But just to review, we have basically 4 types in this configurable model. The first that I have it defaulted to is an edge fillet, and basically it is picking an edge or edges and applying a constant radius fillet, constant value that is. You can make it symmetrical or asymmetrical, so you can apply at one axis away from the edge a certain value and then another for the opposing. So if we were to make this 15, you can see now we have an asymmetrical fillet versus a symmetrical fillet. Also, the profile of that can be defined as an ellipse or as a conic with a row value. So if you look closely here, just as you know the conic tool in Sketch, you can decrease the row value and make this very shallow, or you can increase it and make it rather sharp. So that's very helpful. You also can apply a curve continuous radius, which has a constant curve equal value across the apex of where it's being applied. And you have some other options that I'll get to and a few other models to explain other things you can do with that constant edge radius fillet. So going through to the next one, we have a variable fillet, which is very much like what I just showed, with the exception that now you can define the radius value at certain vertices along the path of that radius. So you can see I've applied at the beginning and the end a 2 millimeter radius, and then I've applied an 8 millimeter radius as it starts to wrap the corner. If I want to apply more of them, then I simply click on additional edges and assign the value there. I'll make these 10 and make this one 10. And you can see that sometimes that it can't understand or solve that fillet. I found in most cases that if you just pick the remaining edges, it usually works. So just give that a try if you're having problems with that by picking all the edges and then apply and make sure that you have fillet values at the vertices. So with that, let's go on to one of the more creative types, which would be face-to-face. So face-to-face is an interesting one because it does not require that you pick an edge. You basically pick between 2 faces. We can do a very simple one here by creating a new fillet here and picking this face and this face, and you can see that the edge is really ignored. It's really seeing the faces to fillet between, and if you have tangent propagation on, it'll do that with that selected face and assume that all faces tangent to it will also want to be filleted. This is really valuable if you are trying to jump over some other geometry. Say you have a chamfer here, or you have some small faces along this edge and you want to actually just get rid of them, you can do a face-to-face fillet. What makes it more interesting, as I explained, is if you first lay down some split lines like I've done here, you can use those to define your fillet. So with this face fillet, what I've done is to create a face-to-face fillet between that split line face here, which is in the pink, and then the upper split, which is in the blue. If I don't select any hold lines and just make this a certain value, say 5, you can see there's a default face-to-face fillet. If you want to just hold on to one split line, you can pick that split line, and you can do a circular fillet. So what results is just the line itself is what's determining the fillet value as it goes along. Now, if you want to use two split faces between those adjacent faces, then you really need to make it continuous. So let's add that second hold line here. And you can see that the constant won't work. Well, that's because geometrically it's impossible for a constant to work, because this value or the distance between this upper edge and the lower edge are different. So that's when you want to switch to curve continuous. And with curve continuous, it can be any profile shape as long as it meets the condition between those two split lines. So that is the face-to-face fillet with curve continuous and dual split lines. There's one other option here I want to show you. If we were to go back to just our symmetrical fillet, you can also do what is called a chordal width. And you can't see it very well in this model. I'll show it in a later model. But these faces, as they're all perpendicular to each other, if these faces angles were to change drastically, then the fillet value, that is the start of the actual fillet edge and the end of it, would vary. So I'll try to get into that in a later model and show you that. Okay, so moving on to our last will be a full round, and this is probably the most simple of all of these types. And if we roll into that, you can see basically what you're doing is, and I'll just recreate it here, you're picking three faces, basically the start face, and then if you right click or do a tab, you should be able to drop to this one, and then tab again and go to the finishing face. And it calculates that fillet value or arc value, determining the distance between the first and the last face. Right now it's constant because these the top and bottom face are concentric to one another. But if they weren't, it would still calculate it. So it's a pretty handy fillet type for doing this kind of feature. So let's move on to some more complex fillet applications. Now, as far as product design is concerned, fillets are important. They are aesthetic. They're also very important for mold flow, to make sure that you don't have any sharp edges that are creating some turbulence when the plastic injects into the mold. And let me just roll forward here and talk about a few things. So here we have an intersection of this strut with this other strut, and we need to fillet it. Now, you might be tempted to, and it's completely fine to put a variable fillet between these two. If we put a constant fillet, I can show you what the result of that is. Now, a constant fillet, because the angle of incidence changes between these two faces, it seems that the fillet itself actually grows. It's really not, but the visual result is that it grows, and that in a lot of cases is undesirable. So the next thing that would be applicable for this is to put a variable fillet there and decrease the value in the rear. So let's go ahead and do that. In this case, what is interesting is that it's a closed loop. So let's go ahead and put in an 8mm value here. And then let's try to put in a 4mm value here. Closed loops are tricky, and in some cases don't work for this type of application. Now I noticed that I'm in metric here, so let's switch to millimeters and try that again, because I was thinking millimeters. So let's make this 8, and let's make this one 4 and see what we get. Yeah, it's more like it. So now we're getting something that looks somewhat constant, and then we can continue to apply values here. This seems to want to be bigger, and again on the other side we want to do the same. So we could tweak on this probably all day and never get a result where this edge is straight. And that's the issue I have with the variable fillet, is it's very hard to control. You might have experienced this yourself. So I think in applications like this, the better alternative is to lay down some split lines and use a face-to-face. So what I've done here is I've very quickly created some split lines. So from the top view, I've created a ellipse, and I've split this outer face. And then from the right view, I've created just a very simple sketch line and split this face. Now I calculated to put a little equation, not an equation here, but some geometry to say that I want this length to equal this length, so I can get something that looks fairly constant in the back. And so we'll split that face. And now we have the ingredients to do a face-to-face fillet that I think will turn out much nicer. So if we go to face-to-face and we just pick these as our two face types and then start to apply, remember it needs to be curve continuous because we're applying edges at both regions, and then drop down to hold line and pick these as our hold lines. And then we can also make it either, well, no, it has to be curve continuous. We can finish out our curve. And so this is really the result I'm looking for, something that's very symmetrical, constant as it goes into this upper strut, and very smooth as it radiuses into the lower strut. So that is how you would use the face-to-face fillet with hold lines. Okay, so I want to explain another option in filleting that can be pretty valuable in a lot of situations. Let's apply a, let's say a 10 millimeter fillet along this edge. And what I want the resultant fillet to do is to not do a fillet completely between the top and the side faces, but I want it to actually stop short of this edge by a certain value. So there is an option that you can use to get that type of result. If you flip down to or expand the fillet options, you can use keep edge. Now in this case, it won't work. What you have to do is to create an edge to be able to stop at that edge. So if you want that kind of result, then you can do an offset split. So I pre-created an offset edge of this top face, and I'm essentially going to create a split line on the top with that sketch. And so now I have an edge there. Let's go ahead and reapply that fillet. Let's see what happens. So if we go ahead and create a constant edge fillet by 10, and then drop down to fillet options, and instead of default, use keep edge. Now what we have is a result like we wanted to lead in, but we wanted to keep the edge at the top. So that's a opportunity to use this option called keep edge. And keep surface is kind of the opposite of it. If you want to keep the surfaces and have the edge stop at the surfaces, you can do the same thing. So those are some interesting and valuable options that you can use when applying fillets. Another fillet option that can prove useful is starting with SolidWorks 219, you're able to do partial edge fillets and chamfers. So I just did a chamfer here, but remember that also starting with 219, I believe, you have the ability to convert a chamfer to a fillet and vice versa. So you can do a partial edge fillet, but you can also do a partial edge chamfer. And in this part of the dialog, you see it expanded here where you can do that. Let's switch back to the chamfer and show you how that's done. Basically, you select an edge and then you have the ability to pull back by a certain distance or percentage. You can also use a reference, and in this case, as you can see here, I've actually created some 3D sketch points where I'm pulling back the partial fillet to that 3D sketch reference. So therefore, I can parametrically control the width of that partial fillet or chamfer. And then the rest is just pretty much filleting. Now, there is one catch to that partial fillet, is that if you have an edge that shares other tangent edges, it's not going to work. I had some fillets here along the back. Let me go ahead and unsuppress those, and you can see it's going to fail. And I guess there is a limitation. The limitation is that the edge that you're picking to pull back partial edge on cannot share a tangency with any other edges in the model. So if you really need to do this, you might want to consider some reorder like I did to do that. And that's pretty easy, actually. I'll just reorder this past this and I can get on with my work. So that's a limitation, but partial edge fillet, it's a feature that came again from the 3D Experience products. It's a CATIA feature that has existed with CATIA for quite a long time. And as you know, the 3D Experience products are built on the CGM kernel that CATIA uses. So that's a nice feature to have over in SolidWorks also. Another quick point to mention is when you're doing fillets, especially constant fillets, and doing it on parts where you have to apply lots of fillets, take advantage of the selection that is with that when you do apply fillets. So in this model, I need to apply some 1mm fillets in a lot of these interior ribs. Do yourself a favor, if it's a symmetrical product, first of all, only build half of it and apply half as many fillets and then mirror everything. Another thing too is to keep your fillets to the end. And this is important for this selection feature because when we go in and start selecting to use the smart selection, it's going to, if you see any other fillets along that face, it's going to pick edges you probably don't want. So what I'm talking about very briefly here is I'm going to do a constant edge fillet by 1mm and pick this edge, and immediately I get a helper. And when I get that helper, I can go and look for faces that I want to fillet all at once. It's kind of like a super macro. And this is a very valuable tool when you have lots of features like this. I think in this case, I just want these vertical edges. And so you can see it just immediately populates your selection with those fillets. And then you can do this just a couple times to get your fillets to work. Now, what you do have to watch out for, depending on what kind of geometry you have, is sometimes it's not going to work. And in that case, you want to pick additional edges or remove additional edges. But at least you have all these edges already selected. So I suspect that these edges here need to be added to my selection. And as soon as we get a preview, we can see that working. Okay, that is not working. So I have to do a little bit more investigation to figure out why this is not working. Let's take a look at the rest of our property manager. Well, they're curve continuous. That could be one reason. That is the reason. So we really only need a symmetrical round on these. So I'm going to go ahead and finish those. And then I can move on. It's just the same process as I move down the line. If I want to do all these ribs, I pick these, and then I pick my helper, and then I look at my selection, I accept it, and it's a very quick way to apply lots of filleting. So don't miss out on that helper. It's going to save you a ton of time when you're doing these kinds of fillets. So it looks like I'm running out of time in this episode, and I have some other examples of fillet solutions that I'd like to show you. So I'm going to continue into episode 15 with another set of examples. So just stay tuned for that, and look in your YouTube for episode 15. It'll be a continuation on fillets.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.